Hello everyone and welcome back again to object detection using AI and deep learning. So for object detection here we are using OpenCV, Python and Raspberry Pi 4. So let's get started. I assume that you should have attended and listened our previous tutorial regarding object detection. We have already discussed pedestrian walking and cars detection also. So similarly in this series we have one more tutorial. So here we'll be detecting face of a person. So in any image or any video it's going to just detect a face and we're going to highlight that. Okay, all right, let's go to programming and then Genie. Okay, so we have got the code here. So here we are detecting face in a video from the live video. Okay, so for this we are going to import numpy, numerical python and cv2 opencv package, and then here we are using cascade classifier defined in opencv. So we have to give here the har cascade frontal face default.xml file. Okay. So since it is not present in present directory, I have to give the path here. So cascade classifier, what does it do is it classifies the object detected, okay, from this file using this file. Okay, so frontal face has default.xml. This file has got a set of features which are used to differentiate objects from other objects. We have to differentiate our desired or you can say target object from other objects. An image can have many objects, so cascade classifier will be differentiating and separating the face object which we are going to zero in on using har cascade frontal face xml file. Okay, so face cascade is going to hold those objects in this variable, and then we are capturing the video from the live camera. Okay, so video capture is a function which is defined in cv2 package, and that we are storing in cap variable. Here we are going to set the video width and height, okay, using cap.set function here, and again cap.set function for the video height. All right, now we are going to enter indefinite while loop. So we are telling that the condition should be true, it should loop indefinitely without any condition, and then when we say cap read, it's going to read that image, that particular image at that particular moment into img and ret variables. Okay, so now we are going to use, as discussed earlier, detect multi-scale function. This function will be used to highlight, and here we are going to put an outline. For example, we can say put a rectangle on the detected objects. Okay, so for that we need the image to be in grayscale form. So here using cvt color function we are going to convert RGB to grayscale image. Okay, so this img is the input variable image, and then we are going to use a flag that is cv2 dot color bgr to gray. This is the code which is used as an input argument to convert to gray from RGB. Okay, so when here we are detecting objects using detect multi-scale function, so it holds arguments as gray image in input image, and in scale factor I have written here specifies the image size to be reduced, and minimum neighbors specifies the number of neighbors each rectangle should have to retain 8. Okay, and then minimum size, beyond this size, I mean the size shorter than this will be ignored, so I'm just using this argument as minimum size 20 by 20. Okay, so all these face objects will be stored in faces variable. Next, while remaining in the same while loop, we are going to enter for loop, which will be actually drawing rectangles on the detected objects. So x, y, w, h are the width and dimensions of the rectangle, okay, which we are going to draw here. So that rectangle we are going to draw is a rectangle function. So cvt.rectangle function is a function used to draw rectangle around the boundaries of the detected object, that is faces. So img is the input image, x comma y the coordinates, and this is the height and width, okay, and then this is the color which we are going to define. This color is in reverse manner, th that is blue, green and red. So when we say 255, 255 is the highest color, highest range, value range in blue color, so it's going to be a blue colored rectangles, okay. And this is again a scale factor, the thickness of the outline of rectangle. And this is, here we're going to extract region of interest, region of interest using grayscale space model, and here ROI underscore color variable is the region of interest in of color image variables, okay. And then we are going to display the image, the resultant image, using IMShow function, and when it loops continuously, this is going to be a video form, okay. And then we are waiting for the user to press escape key to break, and then we are going to release the camera, and after that we'll be destroying all windows to exit the program. Okay, let's see. I'm going to tools, I mean build, and go to execute, and then let's see how it's going to detect images. For this I'm going to show images taken from mobile, because I've got beautiful photos here. So I'll be displaying those photos and showing to the camera so that it detects faces. Let's go. Alright, this is a face I've got from the internet. It's detecting the face. Yeah. So you can see it is detecting faces. Even if you appear on the camera, it's going to detect the face of your face also. So anyone coming in front of camera, it's going to detect the face. Alright, so this is enough to get started, and go ahead with the AI. And this is one of the basic tools where you can just learn and build your own artificial intelligence programs. So hope you understand this. You can put your queries in the comment box. If any doubts, you can always ask. So see you next session.